How much can you accomplish with only 3% of your time? If you're Elon Musk, you serve as CEO of a neurotechnology company called Neuralink. That's right, Elon Musk spends 90% of his time on SpaceX and Tesla, about 2% on the Boring Company, and 3 to 5% on Neuralink. Neuralink was founded in July 2016 by Musk and 8 others and is headquartered out of San Francisco. On August 24th, 2017, Neuralink filed a Form D to the Securities Exchange Commission, or SEC, to disclose the funds that they have raised. Privately held companies that raise capital are required to file a Form D with the SEC. Let's take a quick look. Here is the Form D, and it shows that Neuralink raised close to $27 million. What will that money be used for? In the short term, Neuralink is aiming to bring to the market a product that helps with severe brain injuries due to stroke, cancer lesion, among others. And they hope to accomplish this in about 4 years. But Neuralink wants to do something far more fascinating. And at this part of the video, there is no turning back. You take the blue pill, the journey ends, you stop the video, and believe whatever you want to believe. You take the red pill, you stay in Wonderland, and I show you how deep the rabbit hole goes. Alright, follow me. Neuralink aims to create a device that can be implanted in the human brain so that people can merge with software and keep pace with the advancements in artificial intelligence. The device will improve memory and allow direct interfacing with computer devices. Tim Urban from waitbutwhy.com wrote an awesome post about Neuralink. According to Urban, the device will be so integrated in your brain, you will feel like it is a part of you. You will be connected to the cloud, with your computers, and even with other brains with similar devices. Here is an interview with Musk at the 2016 Code Conference.
And I don't know if a company that's working on it seriously is a neural lace. Going back to the AI situation, if you assume any rate of advancement in AI, we will be left behind by a lot. So far below them in intelligence that it would be like, a pet, basically.
Pet, that's what I was thinking.
Like a pet.
Cat.
Like a cat.
Elon
like
the
a house
cat.
cat. Yeah, it would be like the house cat.
Right.
Honestly, that would be the benign scenario. Mm-hmm. I mean, I don't love the idea of being a house cat.
Okay.
So what's the solution?
Yeah, so I think one of the solutions is to have an AI layer. If you think of like you've got your limbic system, your cortex, and then a digital layer, sort of a third layer above the cortex, that could work well and symbiotically with you. I mean, just as your cortex works symbiotically with your limbic system, your sort of a third digital layer could work symbiotically with the rest.
This is something that's surgically inserted or bred into the species, or what?
The fundamental limitation is input-output. So you have more power than the President of the United States had 20 years ago. That you can answer any question, you can video conference with anyone,
right,
anywhere. You can send a message to millions of people instantly. You can just do incredible things. But the constraint is input-output. So we're I/O bound, particularly output bound. I mean, like your output level is so low. It's like, particularly on a phone, like your two thumbs are sort of tapping away. This is ridiculously slow. Our input is much better because we have a high bandwidth visual interface to the brain. Like our eyes take in a lot of data. So there's many orders of magnitude difference between input and output. Effectively merging in a symbiotic way with digital intelligence revolves around eliminating the I/O constraint. So it'd be some sort of direct cortical interface. I mean, there are a few ways to approach this, but some sort of interface directly with your cortical neurons particularly.
But doesn't that imply surgical insertion?
Not necessarily. You could go through the veins and arteries because that provides a complete roadway to all of your neurons.
He points out that our major weakness is our information output. We have loads of information in our brains, but we communicate the information slowly. And as I type this script, I totally wish I had a neural lace right now. The neural lace would work by an interface working with your cortical neurons, and the interface would simply be injected into your veins and travel to your neurons. That is absolutely wild. But what do experts think? Eliza Strickland from spectrum.iee.org wrote an article that got neural research experts' thoughts on Elon Musk's Neuralink. Neurologist and CEO of Synchron, Thomas Oxley, invented the stentrode, which is a neural probe that can be delivered to the brain through blood vessels, and is planning its first clinical trial for 2018 in Australia. Oxley says, if Neuralink is working on a similar delivery system as the stentrode, it will take a long time to get to the point where Synchron is at. It took Synchron 2 years working with sheep to deliver the catheter delivery system alone. And then electrical engineer professor at Berkeley, Michael Maharbiz, who is working on neural dust, which are wireless electrodes that can be scattered throughout the nervous system to record signals. The obstacles that Maharbiz is facing include circuit design, materials, communication schemes, and power. And he says developing neural dust is a difficult multi-year endeavor. Based on the experts, Neuralink is not trying to do something impossible, but it sure is a moonshot. Remember at the beginning when I said Neuralink was founded by 8 other people? Those 8 other founders are actually a super team of talent that hopes to make Neuralace a reality. There is Flip Sabes, a UC San Francisco professor who has worked on brain-machine interfaces. There is Ben Rappaport, a neurosurgeon with a PhD in electrical engineering and computer science from MIT. DJ Seo, who studies at UC Berkeley and designs brain-machine interface concepts. Paul Merola, who has designed more than 10 brain-inspired chips. Vanessa Tolosa, a researcher of biocompatible materials at the Lawrence Livermore National Laboratory. Max Haddock, who worked on brain-machine interface technology while at Duke. Tim Hansen, a researcher at the Berkeley Sensor and Actuator Center. And Tim Gardner, a professor of biology at Boston University who has worked on brain-machine interfaces in birds. So you see, Neuralink has an impressive talent pool in the co-founders alone. This doesn't even account for any scientists that they hire. Alright, so when can we see the neural lace? According to Musk, he believes a neural lace can be completed in 8 to 10 years. While that may seem crazy to some of you, Musk is serious about the importance of keeping pace with the advancements of artificial intelligence. And if Musk is correct, the best case scenario is that we become house cats. Then imagine what the worst case scenario might be like. Alright, that's all I have for now. I hope you enjoyed your journey. If you did, please leave a like. And if you want to know how cool life will be like in the future, join the NeoScribe tribe and subscribe. I am NeoScribe, and this is the end of our journey.